Hi everyone, welcome to this presentation. I will be taking you through how to build a resilient analytics ecosystem in a high impact environment with a sprinkle of AI. My name is Tafida Balarabe and I'm a Senior Data Analyst Engineer 2 at Revolut. During this presentation, we'll be going through an introduction into what I do at Revolut, then I'll also introduce the topic, then we'll discuss the problem at hand, then we'll discuss how to approach this problem and how to solve it, during which we'll go through a high-level architectural design, and then we'll go into the details of this architectural design before we finally conclude with a summary of what we've discussed so far. So, my name is Tafida Balarabe. I'm a Senior Data Analyst Engineer 2 at Revolut. I maintain our entire data infrastructure in terms of providing data access, data management, data governance, data discovery, in order to make sure that we're able to provide value to all of our consumers, which are mostly employees, and to support the company's goals as well as any form of regulatory reporting that might be needed. I've been doing this for over 4 years now, and I'll be taking you through how some of the lessons I've learned and how to build a very resilient ecosystem if you have this opportunity as well to do that in a fast growing environment like Revolut. This quote you have here is a very interesting one. Of course, I didn't bring up this quote, but something that I learned early in the days of my career, and I think it's really super important. So it says the best type of data is the data that doesn't require you to defend its credibility. So what this means is that you want to be able to provide data that stakeholders trust and can believe in, so that way they don't have to think, oh, is this dashboard working fine? Can I trust its numbers? And how do you get to this stage? Is by having a robust ecosystem. So, what are the problems that we typically have in different data environments across different companies? Many of the things that tend to happen is many teams have multiple OLTP systems, inconsistent schemas and schematics, fast changing business needs and ad hoc requests. So this is a very typical thing whereby many stakeholders want to have their own dashboard ASAP, or there's a new business need each time. Another very common thing is a tight coupling between ingestion and analytics. Sometimes you might even see many teams building dashboards on top of source systems, which is a very incorrect approach because it leads to no clear ownership and inconsistency across the entire organization. So these are the problems that typically happens in a fast-growing environment. And the best way to approach this is by building a robust ecosystem, a robust data ecosystem. And I'll be showing you now how to do that. So this is the clear vision. The clear vision here is to build a source system all the way to the consumers. As you can see here, this is where most people will be in terms of a stakeholder, where they will have a BI tool like Metabase, Looker, or even Tableau, for instance. So you want to build a system that follows this approach, or more or less mimics this approach. And by building a system that mimics this approach, you increase trust, you improve performance, your system is scalable, you're able to reproduce stuff, you have no issue with audit trails or any form of retention or investigations, because you're able to reproduce things from scratch if needed. So in the next slide, I'll be discussing each of these different layers and why these layers are important. So the first layer, I call it source systems. We can also call it raw layer. Some companies call it raw layer as well. But basically, these systems are systems that actually have raw data, like the data that exists as is from a particular app or from an API, and so on and so forth. So this is more or less the raw data as it comes. And the way you capture this raw data can be like through CDC, which is data change data capture, or even like batch extract. But the main idea here is that you want to have minimal transformation. That's the main idea. You want to make sure that your data is as is. And why? Because you want to be able to what? Reproduce this data whenever you want. So that's why it's important to have it as is. Then at the same time, you want to make sure that you're storing this data in time partitioned immutable objects. So that means that this data is stored in partitions, which enables query performance as well. What are the best practices you can do to make sure you have a very, very good source system? So a good practice is using schema registry for event formats. So this can involve having a centralized contract information about field types, field names, required fields, which enables like consumers and producers to be able to validate and negotiate like schema changes, for instance. Then you also want to be able to record who, when, from which version of your data is. This is essential for debugging and for reproducibility, which means that whenever there's like a need to reproduce a report or reproduce any form of investigation, you have that source of data that is, the single source of truth to enable you to reproduce it. So yeah, that's why the third point is coming from, which is return your raw data as source of truth. So you want to make sure that there's as little as possible any form of transformation in your source systems. So in essence, by having this source system and by following these best practices, you're able to have the most accurate view of reality, and at the same time, you can have an easily reproducible system for debugging and for reprocessing if needed. The next layer is the detailed layer. So the detailed layer is your source aligned domain data. In here is where you have your OLAPs. So OLAPs are like your online analytical processing systems, which more or less are used for analytics. This is where most data analysts typically work with data from. And you want to build like more or less two types of data sets. You want to build your source aligned, cleaned, deduplicated data, and you also want to build a slow changing dimension data. So these are more or less, they call them T2 tables. That's type 2 tables, and these type of tables are like used for tracking history of the changes of your dimensions. And in here you have a much more clear ownership, because this data, since they are source aligned, they can also imbibe domain ownership. So in here you have like domain ownership, data contract. You can have automated tests for CI and for transformations. So the essence of having this detailed layer, which can also be called domain layer, is you have a domain structure, and teams can depend on this and have SLAs on this, and it enables you to even build your data health metrics around this as well. Then the next layer that depends on the detailed layer is your analytical layer. So here you remember like in the detailed layer it was single, so your source aligned data, domain data. Here you have your cross domain data here, where you combine data from different domains for reporting and for aggregation. Here you can have your conform dimensions, you can have your fact tables built from here. And basically you want to use like your analytical data for fast, consistent reporting. Basically, this is where most of your consumers will be using this data for. So it's typically consumer aligned, and they're usually subject oriented in this kind of in this layer. And the main purpose of having this kind of layer is fast analytics. So you want to make sure you have fast analytics. Teams can easily build data fast and use as quickly as possible. What are the best practices you can use? So best practices, you want to make sure you are defining your grain explicitly and you're enforcing it via test. You want to make sure that you're using conform dimensions to avoid duplicated logic. You also want to use either batch or incremental variations. So this can be like either you want to like capture your data on a tabular or separate system, just like dump, or you, for example, you want to like capture the changes with time as well. You can also do that here as well in the analytical layer. Now, like I was saying earlier on, your analytical layer is consumer aligned. So this is where many of your consumers will be using the data from. So that will be more or less like your reporting analytics, your GPT experience or AI, your BI tools, Looker, Metabase, Tableau, your ML models will all be depending on your analytical layer. Even your Jupyter notebooks, typically used by data scientists, for instance, they will all be using your analytical layer. And this is what we call the consumption layer. So basically for serving data to your consumers. You know, so the main idea of having this consumption layer is that you want to make sure that you have a controlled access over your data. Or for example, maybe you want to build like a semantic layer for business metrics, which is more or less like semantic driven dimensions and measures, for instance. So you can do that here as well. And the essence that you want to make sure that you might be asking that, okay, why do we have to come all this way to allow people to be able to use data? Why can't they use data directly from the source? The idea is that we want to make sure they're not using raw data, because by using raw data, there is potential for errors, there's potential for operational risk, and building the structure to follow this pattern enables you to have a scalable approach. So which means that as your data need, as your company grows and your data need grows, you have scalability because you have a very robust system. So yeah, this is where I come to talk about like the business value. Like what's the essence of all of this? Why do we need to go through all of these steps before your consumers can actually use these data points that you have been preparing so far? So the first thing is scalability and performance. So because you've been able to build all of this data domains, you've built all of these layers, you can have an optimized analytical models, which are going to be very fast for querying. And then as your needs of your company grows, you don't need to find out what are the right sources. You can just easily reuse what already exists because it's all domain driven. At the same time, it promotes provenance, retention, and lineage for audits. So if there's a need to have any form of audit or investigation, you can easily reproduce stuff because, like I said, you're already storing the data as is. So there's never going to be a troubling moment whereby you realize, oh my God, I'm not sure if I'm able to reproduce this data anymore if we have to do that. So because you've built a system, it kind of promotes, provenance, retention, and lineage for audit and investigation. And as a result of this, you then have trust and accuracy, right? Because since your data is consistent, since you have retention, then across teams, you can easily reproduce your report. There is trust. There are no issues about credibility of the data. Then reproducibility, which is one of the big points I already pointed out earlier, as benefits due to you having raw data, is also a business value that you would get as well. Then at the same time, you would also have faster onboarding of new use cases, since like your downstream is mostly using new domain-driven data models. So there's no even need for you to bother too much about onboarding new use cases or onboarding new approaches to your data. And of course, you have better developer productivity, which is also a very important one, right? Data analysts don't have to worry about debugging issues that occur more often than usual if you're actually using directly from the source. Anything else? Yeah, I mean, there's still like a few more things that you can do in terms of like making your system even more robust. You can start to implement data health metrics. So this can be any form of metric to monitor completeness, freshness, or even like validity, for instance, excuse me. And then you also want to implement for your pipeline metrics. So this can be like monitoring like how often your pipeline runs or how fast your pipeline runs. So you want to look at like latency and failure rate. So in here is also very important form of observability that you want to put in place. And because you've already built a very robust system, you then have an end-to-end lineage from source to consumer. So that means you can easily monitor when things go wrong and you can know where to go if things go wrong. And because you have the system, you can be able to put in SLA measurements. So that would be things like mean time to recovery, pipeline success rate, to to improve the performance of your ETLs and the pipeline. And you can also have query performance. So you can have like your performance for critical dashboards. And also, even another important point here that I also want to mention is um, you can also have a criticality. So criticality is like a way to know which of your pipelines are important. So how do you know which of your pipelines are important? It could be anything that is used for anything that is like regulatory, or anything that is like for monitoring like a key risk indicator. These are all critical pipelines. So by having a criticality of critical, you know that you can have a much more tougher SLA. For instance, maybe the SLA can be 1 hour. So 1 hour downtime is the maximum time for this pipeline to fail. And then you want to make sure that you have a quick resolution for that. Then another thing that we can do in terms of like governance and observability is that you can start putting things like deprecation timelines, migration guides, basically change management strategies around this as well, and also access control and audit logging. So here you can even like put in a lot of access controls in terms of allowing what data is supposed to be available for people, and those that are supposed to be available for certain people. So that's more like personal identifiable information, for instance, or confidential data. So you can be able to like implement access control and audit logging. What are the AI opportunities that one can have in this case? Well, because you've built a very robust system, it's easy now to like put in your GPT experience or your AI models or ML models to this. But to do this, you actually need to have. Before I even go into that, let's talk about the first thing, which is like data discovery, right? So because you have this, data discovery is much easy, but data discovery depends on something which is called like metadata. So in this case, you would want to have a robust metadata, which is probably a different topic from this. But the essence is that since you already have a robust system, you then have like a clean, structured, enriched data points of your table, and you can then use this for your AI models to help in natural language interfaces, in natural language interfaces, and for data discovery. So you can then like allow users to be able to like tap to a chatbot or to a search tool and ask questions about what are the data that exist in the company. So the way to approach this is you want to have some sort of minimum metadata for this. So that will be your table name, column description, and then maybe if there's more data available, you can then include things like your freshness, usage start, access policies, PII tags, owners, primary key, foreign key. These are all the data points that you can also imbibe for having a very rich metadata. And once you have this, the next thing you want to do is that you want to build like an embedding for that. So that's more a way giving context to give context to the AI about what it needs in this case. So that will be using like your table name, your table type, your table name, the column type, and then the column description. So that's like giving it context, and then you can build like your embeddings around that. But of course, there's what I'm saying in essence that you need to have this robust system in place so that you can then build AI opportunities around it. So that's like more or less the idea about what I've been saying so far. And the idea, and to do that, you need to have a rich metadata, which will be based on the robust ecosystem that you've built by following this best practices. Then also you can have transformation assistance, you can have metric lineage and explainability, because now you already have metadata available as part of your metrics. You can then be able to have the AI model explain what metrics is being built and how to build even more metrics based on metadata that already exists. So just to summarize, having a robust ecosystem, data ecosystem, is super important, especially in a fast-growing environment, because it allows you to have scalability and performance. It allows you to have agility in terms of onboarding faster new use cases. It allows you to reproduce to have reproducibility, which means you can reproduce uh, reports or even your ML models from scratch because you're already capturing the data as is, like capturing data from the source. Then it allows you to have proper risk and compliance control. So that means that you can be able to like have provenance, retention, lineage, and for your audits and investigation. And it's also leads to trust and accuracy over time because since you have proper risk and control, you have scalability, you have reproducibility, automatically there's consistency and across the teams, and it leads to more credibility among data teams. So in essence, having a robust like layered data ecosystem and allows clear ownership, reproducibility, performance, trust, and it's in essence like more or less turns like brittle data flows into maintainable, auditable, and scalable ecosystem that reliably powers your BI models, so your BI systems, ML models, and your GPT experience or your AI opportunities. So yeah, that's basically it. So I want to say thank you to the product mindset team for allowing me to give this presentation. Of course, there's still probably a lot more discussion that can be said from what I've said so far. So if you want to have more discussion around this, or you have some ideas that you would like to brainstorm with me, please feel free to reach out to me on LinkedIn. Yeah, I'm happy to discuss this further. Thank you so much, and I hope you're able to take a few things from this presentation. Bye bye.